All right, so far we've been converting between scales on a normal distribution, but we've only been converting like one value in isolation. This example here, and the reason why it's a think, pair, share, is because you're doing this twice in one problem. You're converting two values, but you're converting two values to z-scores from two separate normal distributions. And by taking values from two separate normal distributions and putting them both in a z-score, it makes it so that you can directly compare them. So let me explain. If you want, go ahead and pause the video here and try this on your own. Feel free to pause at any time. Okay. Maybe you want a little bit more context before you try it. Okay. You can pause this anytime. All right. So let me explain what's going on. So compare data that are scaled differently. So which is a better score? A score of 76 on a quiz where the mean score was 64 and the standard deviation was 6.7, or a score of 12 on a quiz with a mean of 10 and a standard deviation of 1.1. So let's look at what we got. So what we have is imagine we've got two classrooms and maybe, two different teachers or instructors. Okay. And here's our two classrooms. We have classroom A, and here we've got classroom B. All right. And in classroom A, we have a student who had a score of 76, and the class average was 64 with a standard deviation of 6.7. And in the other class, we had a student with a score of 12 with a mean of 10 and a standard deviation of 1.1. So the question is, which student did better between either class? Now, you can't exactly say that the student who scored a 76 scored better than the other student with a score of 12 because 76 points is more than 12 points. But you see, this was two different classrooms taught by two different teachers. The teacher in classroom A may have had their quiz out of 100 points. The teacher in classroom B might have had their quiz out of 15 points. So you've got two completely different point scale systems. So how do you determine whether the student who scored a 76 relative to their class was any better or worse than the student who scored a 12 in the other class relative to their students? So because they have these two different scales, if we convert both of them into a z-score, then we can compare their unitless z-scores against each other. And we can see relative to their average, relative to their classroom averages, who did better. And we'll have a direct means of comparison by comparing z-scores. So, here we're going to have maybe class A, we'll calculate this here. And over here, we'll have class B. So go ahead and pause it if you want and give this a try. I'm going to go ahead and just keep figuring this out here. You can continue watching if you like. All right. So we have these parameters here for class A. So we're going to calculate the z-score using that formula. Okay, the value of x here is 76 minus the mean, which is 64, all over the standard deviation, which is 6.7. And over here, we had a student score of 12 minus the mean, which was 10, divided by the standard deviation, which is 1.1. Okay, and this will get you a z-score of positive 1.79. So this student says that 76 is 1.79 standard deviations above the mean. And over here, 12 minus 10 divided by 1.1 gives us a z-score of 1.82. So 12 is 1.82 standard deviations above the mean. So relative to each's class, who had the higher score? Well, it's going to be the one with the higher z-score. So in this case, the student that scored only 12 points, where the student average was 10 and the standard deviation was 1.1, they scored 1.82 standard deviations above the class average. Whereas the student in class A did just a little worse than that. Their score 76 was just a little smaller, 1.79 standard deviations above the mean in classroom A. So what we would say is that 12 is a better score because it is the highest above the mean. Okay, let me know if you have any questions.